In this video, we will explore about option pricing models. You can think of these as special tools that traders use to figure out the exact theoretical value of an option. Our main goal is to help you understand how to arrive at the right value for these financial contracts. We will be looking at some of the most popular models used in the trading world today to give you a clear starting point. First, let us look at the binomial pricing model. This specific method was created by William Sharpe in the year 1978. Over time, it has become one of the most popular ways to price options because it is very flexible and easy to understand. Many traders prefer it because it is highly intuitive, making it a great starting point for anyone new to finance. Now, we look at how this model actually works. It describes how the price of a stock or asset changes over time by using something called a binomial tree. Imagine a path that splits into two at every step. We look at equally spaced steps in time and assume that at each point, the price can only move in two ways. It can either go up or it can go down. These moves happen at set rates and use calculated probabilities to show every possible price the asset could reach. When we consider the final verdict on the binomial model, we find it is a very accurate tool because it repeats these calculations many times. However, there is a trade-off you should be aware of. Because it relies on so many repeating steps, setting it up can be quite complex. This also means that calculating the final price can be very time consuming compared to other methods. Next, we move on to the Black-Scholes model. This model was published in the year 1973 by Fisher Black and Myron Scholes. It is famous for being one of the most popular and fast ways to calculate option prices. The biggest difference here is that, unlike the binomial model, it does not need to repeat calculations over and over to find the answer, which makes it much quicker to use. To calculate the theoretical price of a call option using this model, we look at 5 key factors while ignoring any dividends paid during the life of the option. These 5 elements are the current stock price, the strike price, the volatility of the stock, the time remaining until the option expires, and the current risk-free interest rate. By combining these 5 pieces of information, the model gives us a specific price. Let us look at the actual formulas used in this model. The call option price, which we call capital C, equals the stock price times the standard normal cumulative distribution function of D1 minus the strike price times the exponential function raised to the power of negative interest rate times time multiplied by the standard normal cumulative distribution function of D2. For a put option, which we call capital P, the calculation is rearranged to find the value of the put instead. To make those formulas work, we first need to find the values for D1 and D2. The formula for D1 is the natural logarithm of the stock price divided by the strike price plus the interest rate plus volatility square divided by 2, all multiplied by time. We then take that entire top section and divide it by the volatility times the square root of time. Once we have D1, finding D2 is much easier as it simply equals D1 minus the volatility times the square root of time. To help you keep track of everything, let us define the letters we are using. Capital S stands for the current stock price and capital X is the strike price. The small letter t represents the time left until the option expires, which we always express in years. The letter R is the current risk-free interest rate and the letter V represents the annual volatility of the stock, which measures how much the price moves over 1 year. Finally, we have a few mathematical terms to remember. The letters ln stand for the natural logarithm. The n of x represents the standard normal cumulative distribution function, which helps us understand probabilities. Lastly, the letter E refers to the exponential function. These mathematical parts work together within the formulas to help us reach the final price of the option. By understanding these different models, you can better see how professional traders determine what an option is truly worth. Whether you use the step-by-step approach of the binomial model or the fast calculations of the Black-Scholes model, you now have a solid foundation in how option pricing works. This knowledge will help you as you continue to explore the exciting world of financial trading.